Hi, everyone. Thanks for joining us today. My name is Caroline Griffin. I am Riot's Director of Operations, and you have found the Riot Lunch and Learn series, the place where we spotlight all of Riot's partners. I am super excited to have Rob Holt with iCertifi here with us today to give us a talk on IoT Regulatory Compliance 101. Just a couple of quick reminders before I hand it over to Rob. This session is being recorded and will be posted to Riot's YouTube channel and will be posted to the meetup group where you registered for this event. If you have any questions throughout the presentation, please do put those in the chat box and we'll do our best to get to all of them at the end of Rob's presentation. And the last reminder is to just please keep yourself muted throughout the presentation to minimize distractions. But without further ado, I'll hand it over to Rob. Thank you for being with us today.
Hello, everybody. Happy Wednesday. Let's get started talking about Regulatory 101 for IoT devices. Now, the name sounds like we're going to be specially focused on IoT today, and we are. However, as the name suggests, 101, these are the basics. These are the foundational disciplines that you'll need to in many cases, test to and pass to get certifications to legally sell in different countries. So we're not going to go deep into technical standards that apply. That'll be on a Regulatory 102, which will be in the next month or two. So just keep tuned for that. A little bit about who iCertifi is. We are an international type approvals firm and conformity solutions company. Our sweet spot is getting type approvals, which are typically a term that applies to wireless devices, wired devices. For a particular country, they need to issue a type approval certificate. As you'll learn in this webinar, in the US and Canada, we call those a grant. In other countries, they are called type approvals. But outside of our sweet spot of type approvals, we also offer a lot of design for compliance services, helping you with EMC and product safety, reviews as you're going through the prototype stages, project management of different testing regimens, program management. We have some companies that utilize us to manage their program. In-country representation we offer as well as local holder services. We also provide regulatory conformity intelligence in terms of what's coming down the line for amendments and new standards that might apply. We offer country reports, which is typically a wireless report telling you how to set up your devices in terms of frequency allocations, and we'll get into that a little bit in the seminar. And we also have a very specialized iVault certificate repository service that's free to our customers that houses your regulatory compliance documentation. So without further ado, let's get into the problem that I see out there in society. And when I say society, our business. And so one of the problems we have is executive bandwidth. So when you have a startup company, many executives will start off managing regulatory compliance. It could be the founder of the company or a VP. And as time goes on, they end up with too many other issues that they have to deal with. RMA issues, failure analysis, product recalls, hopefully not. But at a certain point, the executives get overwhelmed and they need to sub out these responsibilities to others in the organization. Well, usually on that executive's team, let's say he's a VP of engineering, you're going to have the typical types of engineers, one who designs in specs, right, and parts and generates the schematics and the block diagrams, another possibly who does testing, validation, pre-compliance, and possibly does the formal testing at the labs. Another one may be focused on radio antenna issues. I saw on the attendee list, there's somebody who focuses on antennas listening to me right now. And sometimes they have a technician to support the team. The question is, who of these is supposed to manage regulatory? And if you're a fast-growing company, that, as you're going to see in the next slide, can become a full-time job. So who would be that person if you were to give it to a designated compliance person? Well, he would have to handle he or she would have to handle all of the hardware and regulatory issues. And the kind of titles that I've seen are compliance clerk, compliance coordinator, compliance facilitator, compliance librarian, archivist, and to be honest, it's all of the above at the same time. Now, in contrast, some companies assign these duties to someone on their team, typically a design engineer, somebody who has a distinct job description and roles and responsibilities, and now regulatory is placed on top of it. So they typically will have 2 full-time jobs, and this can lead to burnout. They're always behind, and possibly attrition as they move on to another job. You also have the problem with delegation. Usually the decision maker in a company is an executive who signs the Declaration of Conformity, but they need a lot of help with analyzing what standards are going to be coming down the line that may apply to their device or their system, analyzing the updates to stay in conformity, translating both into the department budget, justifying which systems are families. That's important because they're going to sign the DOC, which is the next bullet. And how do they know that the person they delegated this responsibility to justify that family accurately? And then, of course, the manager needs to be able to hear regulatory information and teach in layman's terms. Sometimes it's hard for certain executives. So this dedicated person, at some point you need to pull back from outsourcing and give it to a dedicated person. And nowadays it can be a very distinct career path. They could eventually become a homologation specialist. And I've seen homologation specialists making 3 times what a design engineer makes, or a corporate compliance officer. But the main point I want to make with all of this is that the buck stops with the manufacturer. These are legal mandates. The authorities in these different countries do not care what a consultant told you. You should be able to tell the lab what tests to run and do not rely on a test lab for a scope. So with that, let's get into the symbiotic nature of this conformity assessment specialist, right? A dedicated compliance person within a company. That person is like a hub with spokes going out to different departments. And as you'll see in this presentation today, almost every single department. But let's first start with the most obvious. Most of these regulatory specialists will be typically housed in engineering department. And you're going to be working on preparing for, right? Focusing on design for compliance. So you're collaborating with the design team to make sure certain principles are being considered as the device is going down the prototype and final manufacturing path. You also need to collaborate on second sourcing options. What are the impacts to swapping out components? Creating the declarations of conformity, compiling and managing the technical files. For product safety, that'll be focusing on constructional requirements of the device, component replacement, agency interface. There's a lot of agency interface with product safety. Any change to a component, even if you think it's passive or non-consequential, needs to be bounced off your NRTL. They may tell you, yes, it is inconsequential, but sometimes they need to note that in the report. There's typically a cost to update something in the report, or they may require certain testing and then an update of the report. But if you add a second factory or switch factories, that's an update to the report. There's a lot of interface with your NRTL for this person who's doing regulatory. As I kind of alluded to earlier, there's going to be a lot of collaborating with management. Management needs you to be able to tell them what the forecast is for spending so you can come up with budgets. And of course, vendor oversights. There's, as you're going to see in this slide, there's lots of different disciplines, lots of different specialists, lots of vendors to interface with and manage to get all of these certifications in place. Operations. Operations typically will handle reuse recycle directives like WE. We has an ITE component to it. They have a battery directive. They have the packaging directive. So you've got three different directives that are all regarding the reuse and recycle. Typically, it's Europe, but as you'll see later in the slide, it's moving on to other countries, and it's quite complex even in Europe to accurately tackle the we. But the operations department needs help with ECO, right? They want to get some approval. Hey, can we swap this for that? We want to add a new part. We want to add a replacement part, a second source part. We had a failure. Can we get some assistance or your insight on why that may have failed? A good example was ESD. We had a company who was having failures in the Northeast and only in the winter. They're getting all these RMAs from the Northeast in the winter. And if you think about it, it kind of makes sense. The air is drier, the potential for ESD is higher, and that's what was happening. The electrostatic discharge phenomena was a little bit more intense in that region at that time of year. So they had to kind of look at the grounding path of that device to mitigate that problem. So you get pulled into things, is what I'm trying to get at. What happens if you want to update a whole system, like a customer improvement version? You have to look at the parts. You have to look at the top level assembly and come up with a plan. What about the accessories when they want to change from one accessory to another? And then, of course, usually logistics is part of operations, so you'll be working with them a lot as shipments are going out, making sure the paperwork is in order. QA department. Here is typically where I see a lot of RoHS and REACH, sometimes Prop 65 being managed. This is where you'll scrub the BOM. You can either do it internally or outsource this. But that is typically something that is in the QA department. And everything I've been mentioning so far, engineering, operations, and QA, it's a symbiotic. I need, if I'm working on a BOM scrub, I need info from QA and they need info from me to get it done. So it's very symbiotic. QA department is concerned about label conformity because they're going to be housing most of these documents. And of course, you've got the document approval process, document control, archiving. It's your documents that you created, but usually it's QA that wants to manage that. There's also QMS preparations and QMS fulfillment. So some companies may not have a full QMS, right, ISO 9001, but they may implement certain procedures that are QMS best practices. And so you get pulled into that. And usually the QA department is good to work with when you're coming up with some type of compliance dashboard that can be utilized by the enterprise. Finance, well, you have to get quotes from all these vendors. Request POs, you have to manage and log the services performed because they're going to look, finance will look to you to confirm the accuracy of the invoices. You have to collaborate with management to set up the quarterly or the project or the annual budgets. Legal, you have to sometimes review contracts, you have to review NDAs. If you're a publicly traded company, then conflict minerals sourcing is required. I have a slide just on that later. Sales and marketing, a lot of times the sales and marketing team need to look to this person, the conformity assurance person, for a country report or a regulatory roadmap. So they want to be able to count the cost before they go into a new country. And of course, they get a requirement from a client who wants to change a device for whatever reason. And so you need to be able to give them the consequences of that, both in terms of time and cost. OEM oversight. So there's sometimes systems, as you'll see later in the slide, will have an accessory that is bought from a vendor. Sometimes it's an off-the-shelf device. Sometimes it's not. But you as the regulatory compliance person needs to be able to look over their shoulder, go through the documents, and validate all of their certifications are in order. Same things if you're going to be able to resell a device. And I've seen that before where a company will buy a device and just resell it, but you have to make sure, you have to do your due diligence to make sure the certifications are in place. Software firmware. There's going to be coordination with the firmware team to ensure that the protocols for the frequency allocation differences in each country are set up ahead of time. So they're going to look to you to tell them those parameters, and then you look to them to implement that. And then you go to the test lab and test it. But you're going to be coordinating with the software team for end use environment scenarios. They may get you pulled into software testing because some of these labs who do EMC might also offer throughput, latency, or interoperability. So they may ask you to take a device and get some testing done for them. And of course, archiving those data sets and reports. And finally, sourcing department. This one you may not have seen coming, but it's important because when you're, especially in product safety, you'll get a request from the NRTL about certain ratings of certain materials like resins, and sometimes you have to work with the sourcing department to ensure from their contacts that we're getting what we're asking for, or in some cases having the buyer push back and ask for a different type of materials or parts that do carry the ratings that are required for that construction. Here is a quick way to kind of illustrate these top level disciplines in one slide. We've got electromagnetic compatibility, product safety, environmental simulation laboratory. This would be mechanical testing, some of which are called out in other standards, as we'll talk about later in this presentation. Substances of very high concern, and sustainability. I put both the reuse recycling and I put the energy efficiency as part of sustainability. So with that, let's jump into the meat of this presentation. EMI. Now, I know that within our industry, there's different definitions of different terms. For my definitions, EMI is the potential for interfering with other devices, where for the purposes of this slide deck, we will call EMC the ability for a product not to be interfered with. So with that said, let me take one step back, especially as I know there are some startups on this presentation today, and take it to a real basic level. If you have a toaster oven, when you plug it into the wall, it's using a type of electromagnetic energy to drive those coils and to make the heat. That is an electrical device, right? It needs that electricity to do its intended function. Let's say you as a manufacturer, though, want to create a very fancy display, and you want to have that display have maybe LED properties, and let's say you put a processor, a chip, just a regular oscillator or a clock switch in there. And so now it becomes electronics. You have both. It's electrical and now it's electronic as well. Now let's say because of Internet of Things, you want to have that toaster oven talk to the router. Well, you're going to need to buy typically a pre-approved module. Since your company's not well versed in wireless principles, you typically will buy one that's pre-approved. But as soon as you do install that pre-approved module in your toaster oven, now it's a wireless device. Now it's a radio. So you've got three things all at the same time. You've got you've got electrical, you have a electronic, and you have radio, RF. So for this slide here that you're looking at, when I say EMI unintentional, that's that second step where the toaster oven has a processor in it. And every device that has a processor in it as an unintended side effect will radiate. It's going to radiate like the sun in every direction. And the question is, as a manufacturer, do you build your device such that it keeps that energy below a level that would demonstrate a low enough propensity to interfere with other devices? Because that's what the whole purpose of this bullet number one is. What's the potential for your device to interfere with other devices? So the way to do that is to listen through a spectrum analyzer or receiver to the device and to ensure that it's below a given limit. So they do that by putting on a turntable that can turn 360 degrees while you have an antenna mast that will be capturing that data both horizontally and in the vertical polarity. So both polarities while the device is radiating in every direction. And one might say, well, what about the floor? Won't it reflect? Yes, they have ground paths or oats that will dissipate the energy, or they have a similar scheme in chambers to reduce the reflectivity issues. Now, they do that in two ways. One is to do radiated, where you're listening to the energy coming off the device like the sun. But there's also energy that can go down the power line, and that's the conducted emissions. So those are the two tests you'll typically see. And you can do one set of radiated and conducted emissions that will cover US and Canada. Canada out of hand accepts an FCC report because of an MRA. But you can extrapolate the US data to cover Australia, New Zealand, Japan, Taiwan, Korea, and the EU. Or you could test the European limits, use that data for all these countries, and then extrapolate the data into the US format. So that is for unintentional. That means that's the electromagnetic side effect of the device that's unintentionally radiating. Now, in Europe, they also do things to the device to try to demonstrate that the device cannot be interfered with. Sometimes referred to as susceptibility, or in my slide, I put immunity. How immune is your product from being interfered with? And so the first two are the inverse of the bullet number one, radiant conducted emissions. In immunity, we're doing radiant conducted immunity. So instead of listening, they're actually flooding in a chamber that device in a bath of energy and trying to see if that energy could make the device hiccup. And then, of course, the conductor would be introducing energy up the power line to see if that can make the product glitch. On the radiated immunity side, the impetus for this would be products that are working near FM transceiver towers, just to give you some kind of background there. ESD we kind of touched on with that one RMA issue, that's electrostatic discharge. There's electrical fast transients that we're testing for, surges, low-level surges. VDI stands for voltage dips and interrupts. How does the device handle brownout conditions? And then sometimes you have magnetic testing needs to be run. Now, you see in the asterisk, this applies to European Union. This is the one country that requires this. However, if I'm not mistaken, the US and the FDA will refer to some European Union immunity tests to make sure that the product can handle certain phenomena and not glitch. Now we move on to the third scenario of that toaster oven analogy, which is introducing a module, a radio module. Now that device is an intentional radiator. So there are tests that will confirm that the product is doing what it's supposed to do in this end use environment around other products. So I kind of alluded to this before when I was talking about type approvals, but in the US and Canada, you are required to go to a TCB. These are private entities that have been audited and authorized by the FCC to issue grants. Fortunately, in the US and Canada, we have what are called a modular approval program, which means if you follow the conditions of applicability, you can use a pre-approved module without having to redo the testing. Now, when I say follow the conditions of applicability, which means the pre-approved module will have a grant issued by the FCC, and on that grant will be some conditions. This means conditions you must follow when you're incorporating that module into your device. If you follow those, then you can take advantage of the modular approval program. If you stray from it, you're going to have to do some testing. But it's a great program. Saves especially IoT companies a lot of money to launch in the US. However, in Europe, while it is self-declarative, which is great, you don't have a type approval or a grant in Europe. That's great in one sense, but there's no modular approval program. So to be fully in compliance, you must retest again. So they want to see that pre-approved module tested in your device, regardless. And let me take a step back. When I'm talking about pre-approved modules in the US, when you go to make your labels, instead of you requiring a FCC ID, you can use the FCC ID of the pre-approved module on your label. In Europe, the label will just show the CE. So in case and I don't think I did mention this before, whenever you see a CE mark on a product, that means that the manufacturer is declaring that they have met every directive that could apply to their device. So you'll see some of those throughout the slide that I'm going to be touching on other aspects, but one of them is the EMC directive, which covers the unintentional and intentional, right? The emissions and immunity side of things. There's going to be a radio equipment directive, which handles the wireless. So if you put CE marking, you've declared that you've met that. There are some other countries that do require in-country testing, like Mexico, Brazil, and China. But most of the countries around the world will accept either an FCC or a European Union report as the base evidence, along with a whole series of documents. And of course, you need to adhere to their frequency allocation requirements, and we'll get to that in another slide. Another thing to keep in mind is SAR testing, specific absorption rate. This is the energy that could be absorbed into a human's tissue from a radio device. So the test for this, as you see over in the right-hand side, is a trough that is in the form of a cross-section of a human body. They fill it with the saline goop. That daisy machine right there, the KUKA daisy, it has an antenna that goes into the goop, and you can't see it, but on the bottom of that cross section of a human body, they will either put a cell phone next to the hip or next to the head, and they document the energy being emitted into the goop. For low power devices, there are calculated methods to allow you to avoid actual testing. So you need to meet SAR in a number of countries: USA, Canada, EU, Japan, and just this year, Mexico. Okay, product safety. In the US and Canada, we have what is called a nationally recognized test laboratory program. It's managed by OSHA. And as you may know, OSHA is the Occupational Safety and Health Administration. They're looking at worker safety. And I bring this up because the legal requirement in the US is not for the manufacturer to obtain an RTL. It is on the employer who's going to buy this device and have any of their workers utilize it. So they are legally required to buy only NRTL listed devices. So at that point, it becomes a market-driven standard for you to meet this. If you try to sell your product through a retail chain, a Best Buy, for example, or through Home Depot, if it's some type of a home improvement type product, or maybe it's a smart home type product and sell it through Home Depot, these retailers will not touch it if it doesn't have NRTL. Part of it is also liability. If that product hurts somebody, they don't want to get pulled into a court situation. And you as a manufacturer, you might want to consider it just on that, not just market-driven standard reasons, but for the liability, that there's a certain level of liability that gets removed when you meet these NRTL standards. So as you see on the right-hand side, I'm using CSA, but there are, I think now 19 or 20 NRTLs in the country. And you license that mark. So the C on the left-hand side represents Canada, on the right-hand side, US. If somebody wants to get an NRTL just for US, then you won't see the C. If they just want Canada, then you won't see the US. But typically when you see this mark here, that means the NRTL mark covers both countries. There is a licensing fee annually paid to the NRTL, and there will be an initial factory inspection. And after the initial factory inspection, you're looking at quarterly inspections, and there's a charge for that, $1,500, $1,600 each quarter, maybe a $1,700 or $1,800 licensing fee. And what that inspection is doing is quarterly inspections are coming unannounced to your factory. They will pull a product at random off the line, and they'll have your report in hand, and they will make sure that you are still making the device as it was when it was passed. If there is an issue, they see components were swapped and not divulged. In some cases, they could, and they have the legal right to shut that line down. So I mentioned earlier, you must, have a great relationship with your NRTL. Always be in communication with them about any changes, because you want to go above and beyond letting them know about any changes. You don't want a situation where they may shut your line down. Very painful. In the European Union, it's self-declarative, as we touched on earlier, but they're using European norm standards, and this is typically under the low voltage directive. As I mentioned before, you put CE on your product, you've met all the directives that apply. In this case, it's the low voltage directive for product safety. And then the third concept, when you're talking about worldwide product safety, is the IEC CB scheme. And this is managed by the IECEE. It's been around, 28, 29 years. They're up to 52 member nations. And if you're going to go in 7 of them, you can tell your testing house, which is typically going to be an NRTL, and they'll also be a certification body. They can test for all the deviations with one set of tests, meaning they can test for the US, EN, and those 7 countries, or if you want all 52, they'll cover every deviation for every member nation. Some are very small deviations, but they'll test for everything. But to keep the cost down, you just tell them what standard, what countries you want to ship into, and they'll test those deviations. And on the CB report, typically page 3 or page 4, it'll call out the countries that report covers. But the base standard is the same. So, for example, in the US, you have an ANSI /UL 62638. In EN, it's EN 62638, and IEC 62638. And if you go to test and measurement equipment, or if you go to other product categories and the standards that apply to those product categories, you're going to see the same scenario where it's the same base device, but they either have the UL, the EN, or the IEC. Mechanical. So ingress protection is something that you'll see that's called out in product safety, NEBS testing, hazardous location standards. But this one particularly has a whole broad spectrum of different mechanical tests that can demonstrate a certain protection against ingress. That's with the XX, where I put IPXX, so it could be IP52, IP57, IP56, and there's a chart that you can find online that tells you what that means, what it's undergone to pass to be able to claim a certain IP rating. But a lot of manufacturers, since the regulatory compliance person is going to these test labs, some of them, like Met Labs, which is now called Eurofins, or NTS, they'll also have a mechanical test lab where you can also run vibration, shock and vibration, temperature cycling, temperature and humidity test. You can have them help you with ISTA standards on your device and also on your packaging for drops. The 3 feet is if somebody drops it out of their hand. The 10-foot is if it comes off of a shelf. And it's a whole world unto itself, but I bring it up because a lot of compliance people in an organization gets pulled into this simply because they're already going to that lab and somebody in operations says, hey, can you have this tested while you're over there? But since, as I mentioned on one of the slides, that is a very symbiotic relationship, it's going to be expected that you're going to help out with certain mechanical aspects, working with the mechanical engineers in a company. Substances of high concern. Gosh, about 8 years ago, RoHS became part of CE marking, and it went from 6 substances to 10. Most of them are lead and phthalates, but it is harmonized. So when you put CE mark on your product, you're declaring that you have met the RoHS directive. We're in RoHS 3 now, which is really like a 2/3 because it's just an amendment of 2. But it is harmonized, and it's something that you can't avoid, and you can't avoid REACH either. But the difference with REACH is not harmonized. So RoHS bans these 10 substances. REACH limits these substances to a certain percentage, and you're up to 211 candidates, but you have to document that each part is below a certain threshold. And if you're going to open up a bomb for RoHS, you might as well open it up and do REACH at the same time instead of doing one and circling back to another. But REACH is handled a little differently within each of the member nations. They're very slight. Now this one is a big deal. Bigger than some people think. This is a reuse recycle requirement, and the basic premise is you as the producer, you as the manufacturer are shipping products into Europe. What are you doing as a good global citizen to either retrieve those end of life or RMA devices, or how do you get them recycled? And how do you track that? There is the WE on ITE, there's the WE on batteries, and there's the WE on packaging. There's 27 member nations, so that's 91 different standards because WE is not harmonized. So that could be a problem, especially when you have over 330 recycling schemes you could join. It can get pretty in-depth pretty fast. It's not as cut and dry as you might think. So you need to really come up with a producer scheme plan that is compliant, but also efficient. So when you do register with the producer scheme, you're going to be giving them a certain level of device information. Why do they need the schematic and the bill of materials? Because they need to know what the materials are in each of those parts as they break it apart and try to recycle it, right? And in conjunction with having a producer scheme in place in each of those countries that you're shipping into, you also need to be able to find a way to track products that do come back to your headquarters or to different companies in your, if you have multiple divisions, what have you. How do you track that? It's not that easy, but the goal is to get it to a 65% reuse recycle rate. And that could be a combination of the 2 metrics. One, products that come back to you, to your company directly from the end user, and the report that you get once a year from these producers that you register with. You combine those 2 numbers to try to demonstrate, and if you don't hit it, but you have due diligence evidence that you tried as best you can, you complied, you registered with the producer scheme, you have a method of tracking what comes directly to you, that demonstrates that you did some due diligence. One of the requirements is that you have a website page, regulatory page, that instructs your end users on how to recycle. There is ready-made art, meaning the companies that I work with, EC4P and the other ones, they will give you a document that you give to your web people. It's plug and play. The people in, let's say, France, put in their postal code, and it tells them where their nearest recycler is. It's a very well-defined system, but it's something that a lot of manufacturers do not put enough time into. And fines are not cheap, and it is spreading. California has a bill right now that's being considered to introduce reuse recycle, as is 21 other states. There's provinces in Canada that are doing the same thing. There are states in Brazil that already have done this. And then there's other industry associations, things like the Plastic Protection Pact. There's up to 9 member nations. And some of these are helpful if you understand what ESG scores are. Some of these pacts that you can join help you with your the environmental part of the ESG, environmental, social, and governance. So some of these regulatory, both we and some of these industry-driven, like the Plastics Protection Pact or Prevention Pact, will help you with your ESG score. Labeling is not something to be messed with. Fines can be issued if your labels are not correct in certain countries. And it's not as hard as some people think. It just is you apply yourself and you do your research, and many times you'll go to the agency itself of that particular country to get the final word on what the mark should be. They can sometimes issue the vector files to be able to make sure it's accurate. But fortunately, some countries, depending on your product, will allow you to e-mark, where if you have a display and you have only a 3-step process, you can allow users to get to the marking information and also other regulatory information that you would typically find in a user's guide inside of your device in the panel. But speaking of user's guides, certain countries do require certain regulatory phrasings to be included, and in some countries in a particular language. So when you're going to multi-countries, this is something you also need to do your homework on and make sure that you have the right phrases, and in some cases, the translations for that country. Getting to the core of what my company, our sweet spot, is type approval certificates. And so these are certifications that your product has met the evidence as well as the frequency allocation specifications for that company, or for that country, excuse me. And within those frequency allocations, and when I say frequency allocation, what one frequency may be allowed in South Africa, in Israel, that might be reserved for emergency responders. So each country has a certain frequency they want your device to work in, and within those frequencies, what channels can you use, and within those channels, what are the power levels? So each country has a different set of requirements. Our company helps people prepare for that, and it will obtain the final type approval. So getting to another perspective or concept in this compliance world is what is the designation of a system? Okay. It is typically these days not just one core device. It's usually a mix of devices. And each of these could be as a standalone, like the AC adapter I mentioned earlier. It's sold at the store as a standalone device, or sold with other products. You buy it and you put it in with your product. Others are more custom, but at the end of the day, you have a mix of devices that makes that device work. So to give you an example, this is a Vocera badge systems. It is a core. This is the core device. When we say EUT is the equipment under test or a device under test, it has a battery to make it work. Those batteries need battery chargers, and that battery charger needs an AC adapter. Each one has similar requirements, and some have unique requirements. The core device, in this case, it's a Wi-Fi mesh-enabled radio, is battery powered, and that's key too. And I bring that up on the slide. When you have a radio device, your testing is severely limited. So you have radiated emissions only. You don't have conducted emissions. And I see a typo here that should say radiated emissions, radiated immunity, and ESD. So you've got radiant emissions to run, radiant immunity, and ESD. That's it. All those other ones you saw on the slide for European immunity, you don't have to do for a battery-powered device. Of course, there's going to be wireless testing, product safety, substances of high concern. And for this product, California Prop 65, and let me just take a quick moment on that. Part of what California Prop 65 is, there's no enforcement bureau or department looking over anybody's shoulder. The citizens of California are deputized to claim standing in court that your product may have harmed them. And so, believe it or not, there are people out there who make a full-time living buying devices and testing it for, there's over 700 substances in the California Prop 65 candidate list. And if they can find something, then they will sue. And typically a company will sue out of court. Now, if you're talking about a device that never hardly comes in contact with a human, the risk is very low. But if you're, let's say it's a television remote, the risk is very high. That you really need to do your due diligence, have toxicology testing, and have a toxicologist write a safe harbor report. In this case, the Vocera badge was a lanyard-worn device, and for the nurses, it's actually touching their skin if they have a low V-cut shirt all day, every day. That's high risk. So that one definitely would be a candidate for testing. On the battery, same thing, because you can see on the back, on this picture on the bottom, there's a black battery in a white device. The battery touches the skin as well. That's the back of the device. So the battery also needs to meet Prop 65, substances of high concern in terms of the bomb scrubbing for that, product safety, battery testing, which is unique to the battery, and unintentional EMC, which the core device would also need to meet. Well, those batteries need a charger. The charger also needs unintentional EMC, product safety. You can have it as part of the core device product safety reports, the NRTL and CB reports, or you could have it separate. And there's benefits and negatives to either way. You also need to have what's called the CEC BCS, Battery Charging System Testing and Registration. So you're going to do energy efficiency on the charger and the adapter at the same time. So you test the adapter and the charger together. Their test is over 1,000, but under 2,000. And you submit that data and the charger information to the CEC site. You register. When you get to the point of AC adapters, again, it needs unintentional EMC. It's going to be part of product safety. Typically, if you're buying this adapter from someone else, they'll already have gotten their product safety. As you see in the picture here, they have UL. There is an EPS, which is for the adapter alone. They want to see the data. NRCan is in Canada, E3 is in Australia. You have requirements in those two countries to upload the adapter info plus the data, the energy efficiency data, to their websites. And for if this adapter is charging a charger, then you need to do BCS testing with that adapter. Now, even some of the, you would think, inconsequential aspects of the accessories, like the lanyard, for Prop 65, that lanyard is touching the skin all day. So while it's probably not, you just want to take a look at it and make sure that there's no dyes or inks that might harm somebody. Same thing with the label. Believe it or not, there are on the packaging directive issues about what kind of adhesives you can or can't use with inks. And as I touched on before under WE, there is a packaging directive. So there's a lot to consider when you're looking at a device. Another one that's specific for this is not regulatory, but this one was because, as I mentioned, that device would sit either in the pocket of a doctor or on the lanyard of a nurse all day. For those nurses who had pacemakers, we did telemetry testing. Georgia Tech Research Institute is the top one that does telemetry testing to demonstrate that device within a certain proximity of a pacemaker can be confirmed that it will not affect the pacemaker. If you are a publicly traded company, then there is what is called conflict mineral sourcing. It came out of, I think, Section 1502 of the Dodd-Frank bill, the Wall Street Accountability Act or something like that. I forget the name of the act, but it came out of the 2008 crash. And in that act, you are required to source your 3T and G, that's the tin, tantalum, tungsten, and gold, from mines in the Republic of Congo and 8 of the surrounding countries. And so you must show due diligence that you're able to source the mine that it came from or the smelter. And then you produce that report with the company's SD report to the SEC once a year. Getting to some fun stuff. We are post-Brexit now, so as effective of January 1st, you are obligated to have a new UK DOC. However, it's still okay to reference European norm standards. So the same standards on your EU DOC will be called out on the UK DOC. Something that is new is that you must have an authorized representative designated, and that entity needs to be called out on the DOC. I see a typo here. Please forgive me. Effective 1/1/22, you need to start marking your product on the device label with this label here, the UKCA, and you must start calling out BSI standards on your DOC as of January 1st of next year. Within the European Union, they have something coming up here in just a few months that also requires you to designate an authorized representative who will hold your technical file for 10 years. But of course, before he does that, he wants to review the technical file. And it's in his best interest to review it and make sure it's ironclad, because if there is an issue that's going to involve fines, that entity will pay the fine, not you as a manufacturer. The whole premise behind this is Europe wants someone on their soil has an office in one of the 27 member nations to be responsible, legally responsible for this product. And if there's a fine issued, it's going to get paid. In the past of these last, I don't know, since 1996, a fine gets issued, it hardly ever gets paid if the person who signed the DOCs in China or Australia or wherever. So they want to change that. Now there is a new DOC format. The DOC format is to be serialized, and it also needs to call out the details of the authorized rep. The requirements of the economic operators, and each of those are each of the people that in the whole supply chain that are called economic operators are the manufacturer, the importer, the distributor, the line of service provider. That would be the last person who sells it to the customer. So that could be a brick and mortar store. It could be Amazon. And Amazon right now has hundreds of people, from what I've been told, working on scrubbing compliance documents of the devices that they're selling, because this impacts them too. So they're required to keep a record of what was sold to whom. That's why you see that the DOC needs to be serialized. Show due diligence that you tried to confirm the accuracy of the certifications. To report incidences of harm to people or property to the manufacturer or the authorities in Belgium. And the manufacturer needs to detail in their technical file what QMS principles they use in the design and manufacturing stages. That's something very new. Something I would suggest to everybody who's considering, startup and just getting their whole program together. ISO has a best practices guideline. The 19,600 series, revised by 37301. It provides how to establish and develop, implement, and maintain an effective compliance management system. So for those people who are going to be the dedicated compliance person, this is a great guide to follow. And with that, I can pass it over to Caroline.
Thanks so much, Rob. Very comprehensive presentation. I'd like to open the floor for questions. I don't see any in the chat box, so feel free to take yourself off mute and ask any questions. In the meantime, Rob, thanks for providing your contact information.
Yeah, hey, I have a question.
Oh, go ahead, Charles. Thanks.
Yeah, hey, so Rob, thanks. This is obviously very comprehensive, and if I'm honest, a bit daunting. I mean, one question is, if you tried to comprehend all of the things that you just laid out at day one of, a new company, new startup, new product, don't even have my first customer yet, you would probably decide to go into a business that's software based. When do these things really become, important to I mean, obviously day one and all this stuff, but I mean, are there some thresholds in terms of volume or size or time in market where these things start becoming more and more of a focus, rather than on, before you launch and send out your first product out the door?
Well, there's a couple of key phases when you're developing a product. One is the concept phase, right? I would like to build this kind of device with this form and function. I'd like to sell it in this country, or for this end use environment, whether it be commercial or residential, right? Those have triggers as to what needs to be complied with. So at the concept phase, it helps if you're a startup to have a consultant on staff to listen to the goals of that device and create a regulatory roadmap at that time. Some of the key other phases, like during the prototype phase, there are certain other key things that need to be done. EMC, design review, construction review for product safety, things that you want to have flushed out at a certain point so that you don't get far down the path, think that you have a final version, and then you fail testing for EMC or safety. You have to redesign things. It's better to make changes, second sources, make your changes, different resin material at that prototype stage is much less painful than waiting till you think you've got a valid product and you have to do a redesign. That's always very painful. Did that answer your question?
Yeah, I know that was helpful. Thank you.
Okay.
Awesome.
I guess just an idea of, like, what would some of those things cost if you're at the prototype phase, getting that consultant to come in and give you that roadmap, as you said, for example.
Typical consultant is on the low end $150 an hour to the high end $300 an hour. There are some labs that can also, who do the testing, who can also offer consultants, senior engineers that have been doing testing for 20, 30 years. That could be, you could pay them an hourly rate. But you're too early in the process to hire anybody to do that. You have to manage it yourself. So you need to bring in a specialist to give you a regulatory roadmap. The regulatory roadmap may take them 20 or 30 hours. So you're looking at a spend of $3,000 or so to have a solid plan that you can Gantt chart against. What tests can be done in parallel, which one needs to be done serially, like EMC is always done before safety. There's reasons for that. But to have a consultant map out a regulatory roadmap so you know what the overall cost is going to be, the timelines, what to plan for when, by this point, I need to have this done. It's very helpful. And I always suggest do that at the concept phase, at the very, at that PRD document, put a regulatory section in the PRD.
Thanks for the question, Charles, and thanks, Rob, for the answer. We'll take one more question here I see in the chat box. How do you decide when to send a product to NRTL for testing? Too soon in the design may change too much in validating tests, and too late, and I don't have time to fix certification problems before shipping deadlines.
Right, I kind of touched on that in the slide slide deck, but that prototype stage is very critical. So when I used to work at Met Labs, we would have these called red flag lunches, where we'd buy the manufacturer lunch and then sit down with them and look at their product and give them the best construction review we could at during lunchtime and for free. trying to create goodwill and lock in the customer, right? Some labs won't do that. They'll charge for construction review because many consultants will charge for construction review. But other labs are much more flexible. So to Charles' point, try out different labs, see which ones are more flexible with their construction review, and do it as early in the process as possible. You want to find any issues as early as possible, mitigate those. So when you feel like you have a valid device that's ready for testing, you shouldn't be afraid of failing.
Super helpful. Thanks, Rob. And with that, we're out of time. If you do have any other questions that come up, please do reach out to Rob directly. As always, you can reach out to the Riot team and we can connect you directly to Rob. But you will, again, be able to find this on Riot's YouTube channel, and it will be sent to the meetup group where you registered. Thanks again for attending, Rob. Always great to have you. Thanks, and I hope everyone has a great day.
Bye-bye.